Hello, everybody. Thank you for the opportunity to be here to talk with you today. I want to cover these basic things. There's a perception that sustainability and recycling are kind of the same, and I want to talk about how that isn't quite true. And then I'm a bit laying the groundwork for some of the other presentations this afternoon that relate to use of recycled materials in food packaging. So I want to give you a bit of an overview of how the recycling process works and talk in general terms about the suitability of recycled material for food packaging, and then very briefly some of the challenges for recycling. Excuse me, and hopefully I won't cough a whole lot up here. So, sustainability and how it relates to recycling. There is a perception out there that's fairly widespread that the only sustainable packaging system is one where you collect the packaging and then you recycle it back into the same exact package again. So closed loop recycling. I'll refer to that terminology again a bit. Thank you. So to talk about that, we really need to start out with what sustainability really is all about. There are a number of definitions about sustainability, but what they have in common is the idea of operating now in ways that really don't mess up the world for those who will come after us, that allow future generations to meet their own needs while we're meeting ours. There are three main components to sustainability. They're pretty widely recognized. So there's the environmental side, which is where I tend to focus most of my attention. But there's also the social side and the economic side. So things like fair trade coffee, for example, would fit into the social side. The economic side is pretty obvious when you think about it. If a company is operating very sustainably, but they're not sustaining themselves, so they go out of business, then what they're doing doesn't last very long. On the environmental side, two main kinds of things. One is the resource availability, and that includes energy as well as materials. And then what are the effects of using those resources? So things like pollution and global climate change and waste disposal and all that whole cohort of things. Again, as I said, there are various definitions for sustainability. There are also several definitions for sustainability as that pertains to packaging. One of the ones we hear about a lot is from the Sustainable Packaging Coalition, which is a US organization. And they've got a whole set of things here that I'm not going to read all of them to you, but I want to focus on some particular ones. And again, this is the question we're looking at. Are packaging systems made from recycled and or recyclable materials inherently more sustainable than packaging systems made from virgin materials that aren't as easy to recycle? And I am going to do a bit of a cop-out and neglect the social and economic sides and just look at the environmental sides because it gets complicated enough from just that perspective. So, picking out the ones from the SPC definition of sustainable packaging that are the most relevant. One says maximizes the use of renewable or recycled source materials. Okay, sounds good. Is effectively recovered and utilized in biological and or industrial cradle-to-cradle cycles. Okay, that sounds okay too. But there's also is physically designed to optimize materials and energy. And these can be inherently contradictory. Something that does the first one might not necessarily do the second one, though the chances are fairly good maybe. But the third one can very easily contradict the other two. So that's a bit of what I'm going to talk about. So, whoops, I went the wrong direction. Okay, before we can get into details though, we need to talk about how we evaluate the environmental aspects of sustainability. How do we decide whether one choice is more sustainable or not than another choice? And I think there's pretty wide consensus that if we only look at one component, we'll make some bad decisions, at least potentially. We have to look at the whole packaging system, not just the primary package. We have to look at the whole life cycle of the packaged product system, not just look at waste disposal. And the reason we have to do this is because if we change one part of the system, that can have consequences that we might or might not have foreseen in the other parts of the system. So a very simple example. If I make if I put my cereal in just a bag instead of in a bag in a paperboard carton, then I'm not going to be able to successfully ship that cereal and have it survive to the supermarket if I still package the distribution side of packaging the same way I did when the cereal had the added protection of that folding carton. And if I waste the product, then I'm pretty much assured of wasting the packaging that contained that product, but I've also wasted the product and therefore incurred all the environmental costs of doing that. So that's the second bullet there that I kind of talked about. The other thing to keep in mind is, while it's not universally true, it is more often than not true that the environmental impacts associated with making the materials, whether we're talking about the packaging system or the product, are larger than the environmental impacts associated with disposal of those things at the end of life. So it's absolutely essential to consider the whole system if you want to avoid, again, bad decisions. Life cycle assessment is the kind of the philosophical tool that, again, there's general consensus about using to help evaluate the sustainability, or in many cases the trade-offs between the different choices. Helps us avoid those unintended consequences. We have to be careful when we're using it. One of the reasons we have to be careful is we really have to think about what we're delivering. So for example, if I am talking about laundry detergent, I shouldn't be comparing weight of laundry detergent or even volume of laundry detergent, because what I really care is how much do I need to wash a set amount of clothes. So we need to think about what the functional unit is. That's what allows us to compare different things on a justifiable basis. When we do this, when we use life cycle assessment, we create an inventory. We look at what goes in and what comes out. And this is from EPA, quite a long time ago, 2001, I think is the date on there, if I can read it. We have to put that into a broader conceptual framework, that we have to think about what are we trying to do with this life cycle assessment. And more significantly, where more problems come up, is we've got those inputs and outputs and we get this huge complex list. What does it all mean? So that very much relates, I think, to some of the conversations this morning, where we have things that migrate into food, but what does it mean in terms of risk? So again, it's the same underlying framework, and I think it's not accidental that the life cycle assessment framework came out of CTAC, the Society for Environmental Toxicology and Chemistry, because the underlying principles are very much the same. So, I said we'd talk about how this relates to recycling, and there's my short quote. The details matter. Just like they did this morning, the details matter. So let's talk a little bit then about the recycling process, and then we'll get back to some more concrete examples. Recycling only happens when we collect the material we're trying to recycle, we sort it so that we don't have paper mixed in with glass, for example, we process it into a useful form, and then we find end markets where it actually ends up as part of either the same or a different product. If any of those things fail, we haven't really recycled anything. We've just maybe contributed a different kind of waste to whatever waste handling system it's going to. So how do we collect things? One of the kind of dividing lines is between households and businesses. There are ways that are more effective for one and for the other. One of the categorizations is, do you pick it up or do you make somebody else bring it to you? So collection or drop-off. What materials are included? Do you collect all kinds of things mixed together, or do you collect individual materials? Do you make this voluntary, or do you make it mandatory? And who pays for the whole thing? All of these details go into the functioning of individual recycling systems, and one of the complexities for consumers is that the recycling system on one side of the street may be different from the recycling system on the other side of the street. And if you think that's an exaggeration, I live half a block from the boundary between East Lansing and Meridian Township. In East Lansing, I have a cart that I put my recyclables in, and everything, it's once every 2 weeks now, somebody comes and collects it. Half a block away, Meridian Township, if you want to recycle, you have to pay extra to your private garbage collection system to provide you with that service. Half a block. And if I go 3 miles the other direction, the city of Lansing has another different system. So it does make a difference. Okay, business. Usually it's simpler, because businesses usually pay by some kind of measure of amount to get rid of their garbage. So if they can divert something out of their garbage, they might even be able to get somebody to buy it from them instead of having to pay somebody else to haul it away. So there in most cases is a financial motivation for businesses to recycle at least some materials. Now that doesn't mean recycling everything, of course. Businesses may even do things like invest in a baler for their corrugated, because they'll get more money if they bale the material than if they just leave it loose, and it's worth the investment. So all those things operate. Typically a hauler will pick up the recyclables. At worst case, they'll get a reduced disposal cost, again, for a selected set of materials. Residential, as I talked about, there's a lot of variation between communities. One of the things that means is you have to continually educate residents about what you expect them to do, because your chance of getting people to participate in recycling are obviously diminished if they don't know what they have to do to be able to participate. So I think I talked about some of this already. There's always a tension in residential recycling between optimizing diversion and optimizing quality, and how do you get people to participate in all of this. So one of the things I talk about when I talk to my students about how recycling systems work is the relationship between motivation and convenience. If you make it really convenient, you don't need as much motivation to get people to participate. But then the quality of the materials is less. If you expect them to do things like sort all their materials from each other, then they have to have a lot more motivation to be willing to do that. Quality of the materials you get will be better. And all of those things then affect diversion and how much actually gets recycled, instead of just taken to the transfer station and then to the landfill instead of directly to the landfill. So all those things go along. Some things that people have learned over the years. For single-family dwellings, curbside collection works best for most materials. Again, convenience. People are more likely to just take it out to the curb than they are to drive to some place that's maybe 5 miles away to take it there. Increasingly, the movement is towards commingled collection, where you put all the materials together. That has real implications for the waste rates at the facilities, though, whether it's the immediate sorting or whether it's farther down the stream. The more materials are mixed together, then the more processing you have to do to separate them out again, and the more potential there is for contamination along the way. One of the things that I guess I should stop talking about is whether you sort at the truck side or at the MRF. Until East Lansing went to its cart system, I put my recyclables in a blue bin, And the recycling truck driver would sort the materials into various categories on the truck. One of the implications for that is when my husband put something in the recycling bin, I never did this, right, that didn't belong, it would be left there. And the idea was that then he would learn the lesson. I don't know how successful it was, but anyway, we don't do it that way anymore. But there is that. If people put into their commingled collection something that doesn't belong, they never know that it didn't belong. I had a conversation with my mother one time about, no, the broken mirror really shouldn't go in the recycling bin. I know this, but I don't think she believed me. Okay, so one of the things that works well for many materials, or for many recycling systems, is to have a combination of curbside and drop-off. One of the reasons for this is the multifamily dwellings where curbside doesn't work as well. The other is you can include materials at drop-off sites that you can't effectively include in many collection programs. Supermarket bags, I think, are kind of the classic example. I don't know about here, but around where I live, just about every retailer has a place where you can take your plastic bags. Plus, we have some drop-off recycling facilities that also have places you can take plastic bags because they're just too much of a mess for the processing facility. So they need to be separated out first to make the whole system work better. So there's all of that. What happens next? They go to a sorting facility, and most places there's a combination of hand labor and mechanized systems to try to sort the materials into major categories. Many materials will then go to other sorting facilities, like a facility specifically for plastics, for instance, where you'll get a finer degree of separation. And then what you do next is obviously depends on the material. The goal is to provide a feedstock. Remember, if it doesn't get into a new product or package, then it wasn't really recycled. Needs to have useful properties, needs to be available at a competitive cost. And here's another of the issues that recycling perennially struggles from, especially with new materials. Nobody wants to use it if they don't know they can get enough of it, and nobody wants to build a system to get you enough of it if they don't know there's going to be a market for it. So again, I don't know. There are ways to break out of that cycle, but they tend to involve government interference that most people seem to get upset about. But again, especially a problem for new materials. So, oops, went too far. So how does this relate back to sustainability? Main thing is that there are environmental impacts associated with the recycling system. You've got to pick it up, you've got to process it, you have energy and emissions associated with that. You have waste associated with the system. You do get credit for the avoided impacts of disposal, but you do have to pay the costs of actually doing it. For many materials, use of recycled content also is associated with some decrease in properties, certainly not for all materials. On the average, the environmental issues or environmental impacts associated with using recycled materials are lower than the environmental impacts associated with making the materials from virgin feedstocks. But it isn't always the case. So, some examples. Glass bottles compared to plastic bottles. The general public, I think, still believes that glass bottles are 100% recyclable. They've got to be better than plastic, right? But when you do the life cycle analysis studies, most of the time, the plastic bottles come out ahead in terms of overall system impacts. Glass usually is more readily recycled. It can usually incorporate more recycled content. That's not always true. It's often true. But plastics generally use less energy for production and distribution. And remember that general rule about the front end typically having a higher set of impacts than the back end. If your closest glass recycling facility is 100 miles away or 1,000 miles away, you might not even be able economically to recycle that glass. So even that top bullet doesn't always work. Rigid packaging compared to flexible packaging is another example where higher recycling doesn't necessarily mean more sustainable, whether you're talking about recycled content or recyclability. Rigid packages use more material, they're easier to recycle. But flexible packages not only use less materials, so they're less bulky, and that means you have less value in a truckload full, but they very often, to optimize performance, use combinations of material that make them very, very difficult to recycle. Studies done on things like coffee in steel cans compared to flexible packages. Several studies have shown lower environmental impacts overall for the flexible packages with zero recycling than for the steel cans with high recycling rates. So again, you've got to look at the particular system comparisons and to make decisions about which is more sustainable. Here's one more example, corrugated boxes. The recycled content affects the strength. So if you use a really high amount of recycled content, but then you have to use more total fiber than if you used less recycled content, you may be increasing the overall system impacts. And of course, that's assuming that the box doesn't fail so you don't damage the computer, let's say, and have to throw it out along with the corrugated box. So all of those things make a difference. All right, so let's get back to food packaging. Apart from the sustainability aspects, there are things about recycled materials that can pose particular challenges, and I'm talking about direct food contact now. I'm not talking about the corrugated boxes or the corrugated tray that the cans might go in. You know, that's not going to matter in terms of these kinds of things. So we can make some generalizations again. Metal and glass, typically not a big problem. We melt them both at very high temperatures. Organic contaminants will generally be destroyed, as will any biological contaminants. No decrease in performance properties. The molecules in a glass bottle don't know how many times it's been a glass before. It doesn't have any effect whatsoever. So if you avoid contamination with things that really don't belong, like ceramics in the glass, for example, there aren't any big concerns. I started out with a little reference to closed loop versus open loop. Glass bottles usually go back into glass bottles, and I'm using the term to include jars if you want to be specific. Closed loop system. Aluminum cans usually go back to aluminum cans. Closed loop system if you ignore the slight difference in alloys between the end and the body, but we're not going to get that technical. Steel cans generally don't go back to making new steel food cans. Part of the difference is that steel can sheet has to have has to be very pure in terms of its alloy ingredients, and the sheet steel is made in very few facilities. The steel that's made in other kinds of furnaces for a lot of other applications is much more distributed in terms of its production. It doesn't make sense to drive a truckload of cans past maybe 5 processes that could make things like rebar to get to a facility that could make cans just because you think cans should go back to cans. So steel is typically recycled in an open loop fashion. But again, those are the general rules. Paper and paperboard. We collect a lot of different things. We've been using recycled paper and paperboard in packaging, not always direct food contact packaging, for a long time. And most of those materials are made from a mix of paper fibers. But unlike glass and metal, when we recycle paper, because it depends for its performance on the physical characteristics of the fibers as well as the chemical nature, the fibers do get damaged during the recycling process, so paper made from recycled feedstocks is generally weaker than paper made from wood. Temperatures are much more moderate. We'll kill off microorganisms typically during drying, but those temperatures aren't high enough to destroy organic contaminants, for instance, that might be there. Plastics situation is even more complex because we have a greater variety of things that we have to separate out. And plastics that are dissimilar don't stick to each other, so typically if we try to use them without separating them, we get something that doesn't have any characteristics that we would care about. Again, different kinds of plastics are either more or less sensitive to degradation and performance. Just like we can mess up the paper fibers, we can have degradation of the molecular structure of the plastics. The melting temperature that we use generally enough to kill microorganisms, but again, not to destroy chemical contaminants. If it did, it would also destroy the plastic molecules themselves, so we'd make our performance suffer even worse. To complicate things, even if we separate by resin type, we may have a mix of food grade and non-food grade plastics. So using recycled plastics or paper for direct food contact is a lot more problematic than using metal or glass. We can do it in some circumstances. So PCR is post-consumer recyclate, and the key to getting PET bottles, for example, that can be used in direct food contact is to control the source materials so that you're not mixing food grade and non-food grade materials, and then to subject the material to intensive processing, and FDA has recommendations for what kind of proof you have to submit to show that your process is capable of removing things that might have gotten in there inadvertently. There have been a couple processes approved for doing the same thing with HDPE, high-density polyethylene. As far as I know, those have not had any commercial application in the US, and it's because of the nature of the plastics, it's a more difficult challenge. Sometimes we can break the molecules down, purify the monomers, build the molecules back up again. Then you have properties that are identical to the virgin plastics, but that's usually not economical, either from a cost standpoint or even from an environmental standpoint. So that's where we are. I'm just about out of time, so get to challenges for recycling. Rigid packaging systems converting to flexibles, single materials going to multiple layers, combinations of materials that aren't easily separated. Those are all pretty obvious things, but some less obvious ones. The Association of Post-Consumer Plastic Recyclers gets really upset with full-body shrink labels on bottles because the automatic sorting equipment identifies the label material, which isn't necessarily the same as the bottle material, and that can cause huge problems. Direct printing on bottles. New plastic resins that get into the recycling stream, but there's no markets for, so those become waste. And then there's the whole thing about coatings and nano additives and all those kinds of things. And then on top of that, we can put price volatility. When oil prices go down, the value of recycled plastics tends to go down. More contamination associated with commingled collection of more stuff. And I already talked about the lack of consistency if you're trying to tell consumers what you want them to do, but the rules differ when you cross the street. It gets pretty complicated. The need for ongoing education, especially with a mobile population, lack of markets. So, yes, recycling and use of recycled content can enhance sustainability of packaging systems, but it doesn't always, and obviously it won't do it at all unless you get acceptable performance. I am a firm believer that not everything should be recycled. My favorite example of what I don't think should be recycled is used disposable diapers, even though there, believe it or not, was a study on recycling used disposable diapers. I don't think I'd buy a product labeled as made from used recycled diapers, but I don't think they put that on the label. You've got to look at the impacts of the additional processing, and especially when it comes to food contact, it simply might not make environmental sense. So yes, PET bottles can go to PET bottles. There's nothing wrong with PET bottles going to carpet and replacing virgin PET that would otherwise go to make that same carpet, the availability of markets is a key part of looking at the whole system. So, did I give you a headache? Questions?